Hello and welcome to the Sideline YouTube channel. My name is Ray, and in this video, part 4 of Fred's left hand, we're going to continue with the build on the hand itself. So previously I've printed the top hand cover, thumb cover and finger covers in PTEG. I did have several attempts at printing the palm in TPE, which is a flexible filament. So my first attempt was this, and I may have shown you this one in the last video. It was a failed print because I had some under extrusion in different places, including not far off the first or probably second or third layer, and then later on towards the end. So that was a failed print. I also discovered I had too much infill, and so it wasn't really flexible anyway. It didn't achieve what I was after. My next attempt, I'd reduced the infill, but it just under extruded the whole way through, so this was also a failure. And I replaced the extruder with a Flexion, so I went from the standard extruder which is a spring tension, to this using the Flexion extruder, and this is much better. It's got a little bit of flexibility. It is softer, but it's still quite firm. So I'll be using that for the palm on the underside of the hand. Now, I hinted in the last video that I was going to use a modified version of this hand, but before I get into that, let's have a look at what the instructions say on the website. So it says, cut yourself some ribbon, 500mm long. That's what this is. This is actually part of a much wider ribbon than he recommends. I think he recommends 16 core. Split it so you have 9 cores and split the end into 3 groups. This one, you can see the first one is actually already red. That's how the cable came. He's also suggesting, and he being Gael, is suggesting put a red line down one side of each of these, and at the other end split them into 3s and do the same marking so that it's easy to identify when in the forearm. This is 9 off that 16 core, with the remaining 7 cores. Strip 1 core off and then do the same thing, 3 at each end on this end, and then split it here and mark one end as well, 1 wire for the positive. And that's all good, makes sense, and will work well for a standard Nervo board install. And this is where I'm going to differ. With the Nervo boards, all of the analog inputs are back on the Arduino Mega 2560s located on the back of the Inmoov robot. And for each input, you require a cord to run back in a ribbon all the way back to those. I'm not planning on running that many wires. So what I'm going to do is run 4 cores from the forearm. Because I'm putting a PCA 9685 in there to run the servos already, I already have an I2C bus. Now, the I2C bus consists of 3.3 or 5 volt, 0 volt for the ground, and 2 signal wires, SDA and SCL. So I can take those 4 wires and I can continue them through. Because it is a bus, I can have multiple devices hanging off them. So I can add in 2 or 3 of these ADS 1115 4-channel analog input units. These are a 16-bit as opposed to the 10-bit that's on the Arduinos, so it's a much higher resolution anyway. It's only 4 channels and we have 5 fingers and 5 finger sensors going in, so I will need at least 2 of these, and I have 2 of these still in their packs without the headers soldered, which will be handy. This is an MPU 6050 inertial measurement unit. This is a 6-axis, so 3 gyroscope and 3 accelerometers. You can have 2 of these on an I2C bus, so that introduces an issue for me because I've already got one in the head, and I have got one in the chest, but it's on a different bus. But the one in the head will be on the same bus as this. So there is a workaround for that, and that's this device. Now, I haven't soldered the headers into this, and this won't be going in the hand. This is a 8-channel multiplexer for an I2C bus, TCA9548A. And there is a service in my robot lab, so I'll be curious to see if that service is working. And that will allow me to split up the I2C bus and put multiples of these on there. So you can only have 2 of these, but by putting them down different buses, I can actually put more in. So I can put one inside the hand, in the palm, so we get an orientation of the hand, acceleration, etc. I can put one in the bicep. Our wrist isn't really doing a great deal other than rotating, so I can actually get a lot of the orientation of the forearm from the hand. And if I put one in the bicep, I also get the orientation of the bicep, and so in theory I can calculate out where the hand is in space. It can also help with self-calibration on the rest of the servos to a point. So I do have a spare one of those in a pack, never been used. Now this last one is proving to be a problem. I did want to put one of these in. These are a MPR121, and it's a 12-channel capacitive touch sensor. So the idea is you take a wire off each of the inputs to a metal pad somewhere, and when you have a body that is able to conduct electricity, approach it, such as your finger, it changes the capacitance, and so it's able to detect that change, and so it knows that it's making contact. So you could put this up to if it approached a metal surface, it's grounded, it would see that as a change as well. Now here's the catch. It is tolerant to 3.5 volt max. This is designed to work at 2.5 up to 6 volt. This will work up to 5 volt, but these devices, which are the AH3503 Hall effect sensors, are designed to work 4.5 to 6 volt, and that's the primary thing we're putting in the fingers today. So I don't think I'm going to be able to add this one today without adding an extra power line. So 5 wires coming down through the wrist. Now I2C is actually a really cool protocol. The way it works is you pull the SCL and the SDA lines up with a high value resistor like 100k to your operating bus supply line. Then when you want to send a signal, you short it to ground. It's very simple in that respect. The SCL is controlled by the bus master. In this case it would be, for me, the Raspberry Pi, or if you have got Nervo boards installed, you could use the I2C on the Arduinos. And you've got in a standard Nervo board setup, you'll have 2 Arduino Mega 2560s, so you already have 2 I2C buses available on the back there. So in theory, even if you're using the Nervo boards to power the servos, you could, instead of running a lot of wires down for each fingers plus power for those, you could just run the 4 wires down and run the I2C bus running it off one of the Arduinos that you've already got installed. Alright, so let's have a look at the way I'm going to do this. But that will need some of these. So we'll need one of these for each finger, obviously, Now when Gael soldered these on, he used Captain tape for the insulation. I'm going to use heat shrink. So this is relatively small heat shrink. It's hard to see on my background there, but it shrinks down very small. So it will actually shrink down around one of these conductors quite happily. So we can insulate all the way up to the unit. In this case, the AH3503. Now the only other thing that I was looking at is having two of these ADS 1115s installed. That gives me 8 inputs and we only need the 5. And I was not wanting to waste those inputs, so I was wondering what can I do with them, and it occurred to me that 3D printers use one of these. And I'm not got everything tangled up again here. I'm not quite sure how it did that. So 3D printers use these. These are a thermistor, 100K type thermistor. And the idea is these are a resistance, and that resistance changes in a known way with temperature. As the temperature goes up, I think the resistance drops. So with that in mind, we could put one of these in the fingertip as well. Poke that up through and into the fingertip, and we can get temperature sensing near the fingertips. So with 3 spare inputs, I've got 3 of these thermistor cables. They are readily available on eBay and they're not that expensive, so it's worth putting that through as well. The wires that come with these are about the same size, or a little bit smaller than these, and they have a fairly large temperature range, so we can actually take advantage of that as well. Now these things are a 16-bit input as opposed to the 10-bit, as I think I mentioned already, so it gives us a much higher resolution as on top of that. The other modification or change that has been made here, thanks to Harrisini on Discord, he has taken the molds, so that's these ones that are part of the standard build, and he was able to create a positive from this negative void, and with that we're able to print out using TPE a thumb. And this has got a little bit of flexibility in it, so I've already installed a magnet in here for testing purposes, and that magnet moves, which is what we need. So I've printed these 4 fingers and thumb in TPE. The material for the mold is not the cheapest here in Australia, and it's another messy substance that I really didn't want to cover myself with. So let's get stuck into pulling these wires in. Once we have our wires in, we can then install the springs, and then once we've got the springs in, we'll look at attaching this to the body of the forearm and putting our PTFE tube in. So let's get started. Now, because I'm not going all the way down the wrist, I can pull this off completely, and I should be able to get a couple of links out of this. But marking the ends is a good idea. I did actually find a highlighter will do it, or a texter. Now, according to the data sheet, when you have a look at these devices, they've got where's my camera control gone? There it is. So they've got sort of two tapered edges and there's a short flat. The labelling is on the short flat, and then you've got a large flat at the back. So according to the data sheet, this side is your positive, middle is your ground, and then you've got your signal on this side. So we need to make sure that our red wire is on the left of this with the numbers facing up. And we also need to make sure we get our heat shrink on before we solder it up. Now in the instructions, Gael has used Captain tape to tape these up after he soldered them. I'm going to use the heat shrink. Okay, so we want the top surface here, so the side with the numbers on it. We want to push that back a fair way, but we want that so it's all the way into the little hole that's in the fingertip. And you can see the black shadow of where the sensor is located, and that's where we want it. And we want to be able to turn these. I may have to secure that back. Now there's a couple of ways I can do that. I can super glue it or I can plastic weld it. Make sure that we can bend the fingers all the way, and that should be all right then. Okay, so that's our first one installed. Let's get our spring in for it. So with our spring, I did have a short bit of this fishing line. This is probably 200 to 300 mil long. I've got some super glue here. I am going to put that on the tips to make it easier to thread through. It's already starting to braid. This is where a little bit of accelerator for the super glue would be handy. Okay, so that's one done. It's not really set yet, but give it time, it will set. Right, so one down. Let's get the spring sorted. So while I was waiting for this to set, it occurred to me that I haven't actually put the mister wire in yet, and that's one of the fingers I'd like to put the sensor on. So let's get it run through. So ideally I'd like to get it out through this same hole here, so that in the fingertip here I can bring it down. Now what I might do is drill a small hole through here for it to appear out. Let's get this in first. And my 1 meter long cable is a bit too long. So you probably can't see this. I've got it up to this joint here. Just come out the bottom here. Now these wires are very thin, so be careful with them. In hindsight, I should have put them in first. In fact, I might just do that. I'm just going to use a 3mm drill bit. Seems a bit big. I might go a bit small, like a 2mm. It is a little bit tight in there. I think I might strip off. They've put some heat shrink tubing on to keep it all together. I won't need that, so I'm just going to strip it off. Should have used a 2.5mm drill. Now we need a fingertip. So this is one I sort of prepared earlier. I've already installed a magnet in there. Stainless steel. These aren't a very strong magnet, but these are a very sensitive sensor. So in through here, bridging's not very strong, so I should be able to puncture a hole through it. I've still got my brim on there from when I printed it. Because this is such a small surface area, I did use a brim. So I'd better cut that off while I think about it. I will make the file for these fingertips available. It was created by Parasini and will be under the same licensing as the rest of the hand is. This probably needs a little bit more cleaning up, but it'll do for now. Okay. That's our first finger sensor installed. Let's get the spring in. So the trick with the spring, feed your fishing line through this. This is only a short length, remember. This is going to be a little more difficult because we've now got this also full of cables. And we feed our fishing line up through there. Okay, so this is where the fun starts. It's also where you definitely want one of these. These are a flathead, and that goes into that hole there. Once you've got it most of the way done up, we can remove our bit of fishing line. Maybe. Don't over tighten him. I think I'm pushing the friendship with so many wires down through there. I maybe should have brought it up and tried to bring my sensor wires down through the middle of the spring. I may yet change that and do that. Alright, let's see. The next trick is we need to bend this over. And why is that? Oh, it's because it's being pushed up by the cables. I think I will do that on the next one. Just run some of my wires through the spring. Right, so with setting up the tension, bend the finger over and we need to put a pin through there, and that will actually stop the spring from springing all the way back and reduce the tension on that part. We then repeat that for this point here. There's a small hole in there. So there's a small hole and there's a small hole. I think Gael used a small nail. I've got a small bit of fencing wire that will do the same job, and I'll just grab it. So this is fencing tie wire, it's nothing special. So what I'll do is I'll put the full bend on that. All the others are straight. and poke this through until it comes out the other side, like so, and then I can trim it to suit. I will trim that down a little bit further, and I'll probably put a little bit of super glue in just to make sure it stays secure. So let's get the other one ready. Again, we pull it to put the tension on. Through that one. Yeah, I think my extra wire is making it a bit hard there. But that's our first finger done. 4 more to go. The thumb and the other 3 fingers. Okay, let's keep going. Don't know that I'll put the sensors in any of the others because it does make it a lot stiffer to bend the tip of the finger. But I am putting the touch sensors in. We'll see how good they are when we're finished. Okay, so the thumb is a little bit different to the other joints as far as the spring is concerned. With the other joints, we're attaching to the finger and then pulling up. In this case, we're going the other way. Now, there is a reason for that, and that is it's a lot harder to get this screw in. So we're going to just feed this through. Should be a bit easier than my dry runs without the cable. Now we do have to put the thumb cover on because the thumb cover fits here. The screw goes through the thumb cover, through the spring, and then into the body of the hand. Now there's not as much tension on this one. But like the other one, we need to put our bit of wire through. So we fully bend the thumb, and with it straight on the next joint along, we poke a bit of wire through. that appears to be working. So that's 2 down out of 5. If anyone's interested, it is taking me about 15 to 20 minutes per finger to do this. Okay, so one thing I haven't done is put the magnet in this one. Now when you're installing the magnets, you will need a toothpick or some such thing, as using a metal tool, these will have a tendency to stick to your tool and not to what you want it to, in this case in the hole. Once you get it in the hole, it should sit pretty flat. You can squeeze it all the way down and that should help locate it in there. We will no doubt put a little bit of either super glue or elastic or something of the like just to hold it there, make sure it doesn't come off. Once you've got that in, then we can push it on. Yeah, that extra wire in there is a problem. What I could do is pull it apart, cut one of these wires back and actually solder it to either the positive or the ground, and that would reduce the number of wires we've got coming back. Reducing it by one would probably overcome the issues, but we'll see how we go. I won't put the other sensors in the others. I think that makes the decision it's going to just be too hard. Alright, let's get the next one. These are very fiddly to get in. Now, I haven't paid much attention to the polarization of these magnets as I've put them in. Now, when there is no magnet present, these sensors at 5 volts will output around about 2.5 volts. Now, depending on the polarity of the magnetic field that's affecting them, they'll either go up or down from that voltage. And I'm relying on that we can then program our robot to acknowledge the difference. Okay, I've still got to put the wires in these two like I have in these two, and then that will bend a lot easier. Now you'll remember I put a nutsert in this one. That's for that middle hole. I may end up putting nutserts in that one and that one as well. I'm not real impressed with how these have turned out without the nutsert, so I may open them up and put nutserts in, and that will go there. This piece then fit over the top, and there are 3 screws that hold it in, like so. Now that leaves these open areas in here which are exposed and not very pretty. So one of the things Gael did with his is he put some high density foam, some black stuff in under here. I don't actually have any of that on hand, but you can buy at cheap stores, $2 shops and the like, this non-slip matting, which will do the same job. So I've had this for quite some time now, so I'll just cut some out, put it under there, and clamp it down with these. Trim it to shape, and it'll look quite nice. That's the plan anyway, so it's going to be fiddly, so I'll do that off camera. I've been on this for about 2, nearly 3 hours, so I might call it quits at that, and on the next video I will wire all these sensors back into these two. I'm not going to put the header on like that, I'm going to hardwire. I will also make up a 4-wire ribbon and bring that out as well. Now the bottom hand cover, you'll see, has these grooves, and that's so that I line it up right. That's so that the sensor wires will go into those grooves, and they all come up here. So I'm not sure, I might put all my sensors in there and put the MPU 6050 in there. I'll think about that between now and when I do the next recording. In the meantime, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I have a Patreon account. There will be a link in the description. And I'd like to thank my long-term Patreons, Go Lucky, Lorenz Berger, who are my VIPs, and my builder, Elmrolls45. If you've got any questions about this, leave a comment in the bottom of the video or drop into the Discord and ask a question there. There is a link for the Discord in the description, and we'll see you in the next video.